Alright, for this next video, we are going to do lesson 89, estimating square roots. And the first thing you need to know is your square roots. So let's go ahead and review that. Alright, so I'm going to do all the perfect squares. Square root of 1 is 1, because 1 times 1 is 1. Square root of 4 is 2, because 2 times 2 is 4. Square root of 9 is 3. So basically, you guys can see the pattern I'm doing here. Square root of 16 is 4. Basically, I'm taking the answer here and squaring it. 5 times 5 is going to be 25, which means square root of 25 is 5. 6 times 6 is going to be 36. Square root of 36 is 6. 49 be 7. Square root of 64 is 8. Square root of 81 is 9. And square root of 100 is 10. Okay, so you guys gotta know this. Actually, you should even know this. Square root of 121 is 11. And square root of 144 is 12. A couple of you have memorized it. Some extra ones. Square root of 169 is 13. Square root of 196 is 14. And square root of 225 is 15. You should definitely know 1 through 10. Probably know through the square root of 144. These three, yeah, you should. Why not? But anyway, memorize these. Know them. Now, how do we estimate a square root? Well, think of a number line. So if I had a number line, okay, boop, and this was square root of 1, that would be 1. Well, here would be square root of 4, which is 2. And here would be square root of 9, which is 3. And so on and so forth. It goes forever. So let's do square root of 16. Make sure these look like square roots. And that would be 4. Now, notice I had square root of 1, square root of 4. But what about square root of 2 and square root of 3? Where would those be? They're not on here. We don't know what those are. Well, we're going to learn to estimate the square root of those numbers. So if I say square root of 3, let's just look at these radicals here on the bottom of this number line. Basically, when you're estimating square roots, you are given a radical. For example, you are given, let's let this be number 1 for your problem, the square root of 2. And our second problem, we're going to estimate the square root of 3. What is that? Okay, so square root of 2. Well, that's clearly going to be, don't look at the top, that's clearly going to be in between the square root of 1 and square root of 4. So what's square root of 2 going to be closer to? Is it going to be closer to this spot or this spot on the number line? Well, clearly square root of 2 is going to be closer to this spot. So square root of 2 is going to be around here. Okay? That's where it's going to be. And so we're going to estimate that. It's going to be not quite. Now I'm going to try to find the top number. Okay, I've given the bottom number, the radical, and I'm going to try to find the whole number, or the decimal number. And so square root of 2, let's say it's going to be 1. It's going to be in between 1 and 2. And a decimal, let's say around 4. That's my estimate. So let's see what the actual, get out my calculator really quick. Okay, clear. So, then I'm going to do square root of 2, square root, look at that. About 1.4142, though I'm not going to worry about all those numbers because we're just estimating. And I said 1.4 or 1 4/10. Boom, there it is right there. Let's see how close we can get for 3. 3, of course, is not, square root of 3 is not bigger than square root of 4. So it's going to come in probably closer to about there. So let's guess that one. Let's say this is going to be bigger than 1 4/10. Let's say 1 maybe and 7/10. I could be wrong. Let's just estimate it. Clear this out. 3 square root. What do you know? 1.7. 3205080756887, and it goes on forever. It's actually an irrational number because it goes on forever. It's kind of like pi, in that the decimal goes on forever and does not repeat itself. But I was pretty close. Okay, so that's how you estimate. All right, that's how you guys estimate square roots. We're going to practice a couple more and go from there. All right, you guys try these next problems. I'm going to start this right away. All right, go ahead and pause your YouTube video and try the square root of 20 and square root of 35. All right, welcome back. Square root of 20. That's bigger than square root of 16 and smaller than square root of 25, so it's in between 4 and 5. So it's going to be 4 point something. We don't know. So square root of 20, is it closer to square root of 16 or square root of 25? I think it's closer to square root of 16. So I'm going to put this right about there, and I'm going to say 4 point, it's not real close, so I'm not going to put 4.1, I'm going to put about 4.4. So let's go ahead and see what this is. Let's say 20. I'm going to put my square root button. Boom. 4.47. Look at that. I was pretty close. If I put a 7 there, then maybe I could round up to 4.5. But I'm going to say 4.47. That's pretty close. Square root of 35. Notice that's really close to square root of 36. I know the square root of 36 is 6. It's not quite 6, so I'm going to put 5 point something. I'm going to try 5.9. Let's see how close I am there. 35 square root 5.916079783, so on and so forth. So I was close. Alright, if you noticed, I changed into my pi shirt. Easy as pie, 3.141592653588979, so on and so forth. It's a number that goes forever and never repeats itself. It's called an irrational number. What I showed you guys today are all irrational numbers. It's a whole series of numbers that the decimal goes forever and never repeats itself. So, that's about all I have. Until next time, keep up the good work.